Hi students, welcome to the class. So in this video class, I will explain you about rules to draw the ray diagrams of a convex mirror. So what are these rules? Simply these rules are nothing. Here simply we can use particular rays. What they are? One ray parallel to the principal axis, one ray to meet focal length or passing towards the focal length to meet, and the other is towards the center of curvature. So when these rays are incident on the convex mirror, after reflection, how they are going to be behave. So that we can learn in this topic. So for this, just you need one plain paper or use your notebook horizontally, not in a regular position, vertical position. Just use in the landscape position. So horizontally use it, and just draw your convex mirror, selecting that horizontal position and left side to the notebook in the middle. So here, after drawing a convex mirror as shown in the video or on the screen, just locate its pole and center of curvature as well as focus here, right? So here for a convex mirror, that center of curvature and the pole is located behind the mirror as you see here. So complete this process first, then join a center of curvature and the pole, then it is known as a principal axis. Extend this line in front of the mirror also. So here, why this? Because here principal axis we can use to put the object on it. So here we are not going to use the object, just we can use rays, right? So first here I will use a parallel light ray. Then the second one is the light ray which seem to meet the focal point or a focus. Here it won't meet, actually it appears to meet. Then the third one is towards the center of curvature or seem to meet the center of curvature, right? So these are the three rules we are going to learn, right? So first one is parallel beam of light ray. So here only one ray I can use. What happens if a parallel light ray, that means which is parallel to the principal axis. So if a ray incident on the convex mirror which is parallel to the principal axis, after reflection, what happens? So first draw a line parallel to the principal axis to meet the convex mirror. So here just use one logic here, that is use that gap between the parallel ray to the principal axis, just exactly width of your scale. So it is exactly parallel to the principal axis. So draw as you see here. Then we need a normal here, right? So normal is, as we learned here, for the curved surface is radii. So construct a radii towards the point of instance using your scale. Just look at here I am drawing using the scale. So join that, then extend outside of the mirror also. But here always draw the radii or a normal at the point of instance with a dotted line here. So I am drawing this dotted line. Then next here measure the angle of incidence and note down as the value of incident at the angle what you measured. Then exactly measure that angle another side of the normal. So here in this case, just below the normal you measure the angle of incidence. Now another side above the normal you have to measure the same angle. Then using the protractor, just you have to position your protractor as you see here, measure the angle. Next construct the reflected light ray as you see here. Then here simply what happened, just to know that one, you have to extend that reflected ray in the backward direction as you see here. Then you can realize that reflected ray meets the focus when you extend in the backward direction. So what we can generalize here, if a parallel light ray incident on the principal, not a ray which is parallel to the principal axis incident on a convex mirror, it seemed to be emanate from the focus after the reflection from the convex mirror. So this is the generalization. So this ray we can represent as R1. So we can use this ray in the construction of a ray diagram. Then we will go for the next rule. That is, in this we can consider a ray which meet or directed towards the focus, as you see here. So here construct a ray which that simply use the scale to put here like that on the screen. Then draw the ray to meet the convex mirror surface. Then note down this ray as R2. Then simply, as you followed in the first case, draw the normal at the point of instance with the dotted line. Then measure the angle of instance and angle of reflection also same as the angle of instance. Then construct the reflected light ray here. Then generalize it. So here what happens? So here if you observe any light ray which directed towards the focus, after the reflection it becomes parallel to the principal axis. So this is the generalized rule. So here you may got a idea about a case 1 and a case 2. If you instant a light ray which is parallel to the principal axis, it seems to be emanate from the focus. Its converse is what? If you instant the light ray to meet the focus, then it will become parallel to the principal axis. So very interesting. Then see the last one, that is case 3. It is instant along with the normal, that means which is directed towards the center of curvature. So here in this case that light ray retrace its path, because here angle of instance as well as the angle of reflection is nothing, it is 0, because there is no angle made by the incident light ray as well as the reflected light ray with the normal. So this ray is identified as R3. So these rays R1, R2, R3 which are possible, that rays any two of these three we can use in the construction of ray diagrams. So thank you. Maybe this is helpful to you.